Hello everyone. Today I am going to solve problem 1 which is 2 from the chapter 20 problems of homework 8. So let's go through the question. So question says a magnesium 2 plus which is divalent ion and a chlorine minus ion are 6 Armstrong apart in water. So medium is water, not vacuum, at 25 degrees Celsius. So we have to calculate their electrostatic interaction energy in terms of kT. So remember these things, we are not allowed to calculate kT in terms of joule or kilocalorie. We need to calculate in terms of kT. So before calculating in terms of kT, let's calculate in terms of joule. Then we will go back and calculate in terms of kT. So some hypothesis. So what we need to do? So we have to calculate interaction between a divalent ion. That means two protons from the divalent magnesium and one electron from the chlorine ion. So we need to calculate the energy between these two things. So I already wrote the formula to calculate the U. So U is fancy row Q1 Q2 over D into R. Why we need D? Because this whole thing is in another media, water, and it's not in vacuum, so the interaction energy will be lower than comparing to the vacuum, and we need a D factor. D is basically dielectric constant. So E Q1 Q2 over D into R. So if you just open all those terms, it will be 1 over 4 pi of epsilon q1 q2 into d over r. So q1 here is our charge of the electron, which is minus e. Q2 is charge of two protons, so 2 into e, and we need a Avogadro number factor since we have to calculate in terms of mole, and d into r is the dielectric constant at r. So if you just rearrange this whole thing is e square na over 4 pi epsilon minus 2 into dr. So we know from the book that charge of an electron is equal to minus of 1.6 into 10 to the power minus 19 coulomb. Charge of a proton, which is roughly minus of charge of a electron, which is equal to 1.6 into 10 to the power minus 19 coulomb. This whole thing is already written in page 386 of book. You can see charge of a electron is this, charge of a proton is this, charge of a electron is this whole thing, and also the Avogadro numbers in terms of coulomb units. So this is already in coulomb, but I need in mole. So what I'll do, I'll just multiply the Avogadro number, which is already given as Na is given as 9.647 into 10 to the power of 4 coulombs mole inverse. Okay, all these things are given. Also you can notice from this same thing that they already calculated e square over 4 pi epsilon, which is terms of joule. So they calculated e square over 4 pi epsilon as in joule meter mole inverse. So e square Na over 4 pi epsilon is minus 1.39 into 10 to the power minus 4 joule meter mole inverse. This is from page 386. So I got this. So now I directly need to substitute all the values into calculate all these things. So we can substitute first this value as this and all these things. So e square over this is equal to minus of 1.39 into 10 to the power minus of 4 joule meter mole inverse multiplied by 2, which is our 2, and we need d into r. D is 78.54 and our r is 6 into 10 to the power minus 10 meter. This meter and this meter gets cancelled out. So we will find u in terms of joule as minus 5.8996 into 10 to the power 3 joule mole inverse. Okay, now we need to find u in terms of kT. So kT we can directly calculate from Boltzmann's constant. So Boltzmann's constant in terms of joule is this, and T is given 25 degrees Celsius, which is roughly equal to 298.15 Kelvin. So if we just multiply using a calculator, we will find this whole thing kT as this. Now u in terms of kT will be, you can easily take the ratio. So u over kT, so I'll substitute value of u minus 5.8996 into 10 to the power 3 joule mole inverse divided by kT, which is 4.114 into 10 to the power minus 21 joule. So this joule gets cancelled out. Answer is minus 1.43 10 to the power 24 mole inverse. Now you can multiply this KT here. So this will become minus 1.43 10 to the power 24 KT mole inverse. So now we can write U is equal to minus 1.43 into 10 to the power 24 KT mole inverse. Okay, so now we got our answer. So U in terms of KT. So the key learning of this question is we need to see what's the charge. So here you see there is 2 proton, here is one electron. So this is something different from the example 20.1 where there is Na and Cl structure. So here it's magnesium 2 plus and chlorine ion. So you have to calculate the interaction between 2 protons and 1 electron. And second thing is the medium is water. So you have to always remember if the medium gets changed, this whole thing, the dielectric constant will comes into the picture. So okay, we found our required things. Thank you for your attention. Let me know if you have any doubts.